Hello, everybody. This is the Jacksonville Java User Group International Edition. We have people here from all over the place and also from outside the United States. Yeah, I like to see the responses. You have those emojis that you can use. You also have a place to send messages on the side in the chat or in questions, or raise your hand if you want to join us on stage. This is our meetup for the month of August 2021. We are fully online this month. We had a hybrid meeting last month where some of the people were actually meeting in person, but the place where we held it is closed because of the situation. So we are back to online and hope to go back to having hybrid meetings in the near future. We have an exciting topic today, Java 9 and beyond, and it's brought to us by Helber Belmiro from Brazil. And I'll pretty much make myself invisible now and leave the stage to Helber.
Okay, hello everyone. First of all, I would like to thank to EL for the invitation. It's an honor to be here presenting to you. And today we're going to discuss the new features from Java 9 and beyond, and how these features can improve the quality of your code. So feel free to interrupt me anytime. You don't need to wait the talk to finish. So if you have any question, you can just ask, and that's it. So my name is Helber Belmiro. I'm from Brazil, as he also said. I help Java engineers build libraries and frameworks that are easy to evolve and upgrade so they can stay up to date with technology and work on great projects. I'm software engineer at Banrisul. Banrisul is a Brazilian bank. And at Banrisul, I develop an internal framework that is used by several applications that work as a service. My blog is thegreatapi.com, and you can find my Twitter and LinkedIn accounts as well. So starting talking about bugs, where do they come from? Among others, the bugs come from non-intuitive APIs. They come from code that is hard to read. They come from verbosity. They come from mutable code and mutable objects. And the newer versions of Java, they solve these problems. Pavel is saying, I only see half a slide. Can Jyoti says he sees okay? Yeah, he's saying that did you pay full price?
Okay, I just came back to see what's going on. I see the whole thing. Does anybody else have an issue seeing the entire slide? Oh, you can also, yeah, I have a button that will maximize the view, but either way, I can see the whole thing. Where is Pavel? I don't see his comment anymore. Okay, so it might be on, yeah, Chrome works best with this. If you're not on Chrome, switch to Chrome maybe. Okay, Pavel will suffer. Tell us to continue. Okay, I'm sorry.
Okay, so let's move on. So as I was saying, the newer versions of Java, they solve these problems. They have more intuitive APIs. They are more readable. They have less verbose code. They allow us to write less verbose code and more immutable code, and allows us to create immutable objects. And that means less bugs. So about the versions of Java, we have Java 8 that was released in March of 2014, and we have Java 11 that was released in 2018, and these are two LTS versions which are the long-term support versions. And in September we're gonna have the Java 17, which will be the next LTS version. So probably a lot of companies will be moving to Java 17, and most of companies are using Java 8 and Java 11 at the moment. So what versions are you using? Can you put here on the chat? At Banrisul, we are using Java 11, as I said before. Thiago is using Java 8, Ial Java 8, Joti Java 8, Sydney 16. Oh, interesting. Cool. I hadn't found anyone using the non-LTS versions yet. It's first time. Sydney is cheating. Yeah. Yeah. Cool. So yeah, as you can see, a lot of people are still using Java 8. AJ is saying 16, but I have no professional engagements keeping from testing with each new version. Yeah, Pavel says Java 8. Yeah, interesting. Yeah, most of the people here are using Java 8. Okay, I did a research at the issues from Java, and I found an interesting number. I did a search by bugs that were fixed at versions greater than 9, greater and equals than 9, with status resolved and resolution fixed, and I found 16,000 bugs. It's a huge number, so you can see how much bugs were fixed in the newer versions. Of course, this number doesn't mean that all these bugs existed in Java 8. Some of them were created in Java 12, for example, but still is a big number. And if you want to check this, you can find the link here in the presentation. So starting with the features, yeah.
Just a quick comment. What you can do is when you have important links, you can paste them into the chat, so people can just click on them.
Yeah, I put on the chat. So when I was a beginner, I used to struggle with creating lists. When I wanted to create a list with fixed elements, I never knew how to do that. I started to think, can I pass the elements in constructor? So if we if we check the constructor, we will see that it has 3 overloads. The one is the one with no parameters. We can use define an initial capacity, or we can inform another collection that will compose our list. So none of these constructors can allows us to create a list with fixed elements. So what we usually do, we create an empty list and add each element one by one, and now we have our list with the elements. But it's a modifiable list. If we pass this list to a method, this list can be modified, and we normally don't want to have that. So to make the list unmodifiable, we can call the method collections unmodifiable list, and then we have a unmodifiable list. But there's still a problem with that. Our list, our variable cannot be final anymore. So we have to remove the final modifier, and now we have an immutable object, but now we have a mutable code. So we are exchanging one problem by another one. So it doesn't solve our problem very well. An alternative that we could use is to call the factory method from arrays as list, and to inform the elements from the list. And now we can have a final variable and an unmodifiable list. Very simple, very straightforward, but it's not intuitive. Why would you search a method in arrays class to create a list? I would never find this method by myself, so it's not intuitive. With Java 9, now we have a new factory method, which is found in list interface. So it's pretty readable and much more intuitive. We can find this factory method in the other collections as well. We can create a set of these elements, or we can create a map of these elements. With the difference that for map, we have to inform the key and the value. But it's much more readable and intuitive than the previous solutions. Another feature is finding a class in the stack trace. As a framework developer that I am at Banrisul, it's common that I have to find a class in the stack trace to find some annotation or something like that in the stack trace. And how we can do that? We could call the stack trace from the current thread and find the specific index from the array returned by getStackTrace. And then from the stack trace element, we could find the class name and then create the class instance. I used to do that when I started working in this framework, and I still see people doing that, and I tell you to never do that, because a new method will be added or removed to the stack in the future, and you won't remember to update this index. And probably you won't notice that this is happening, and when you notice it will be too late. So it's not a good idea to use the fixed index here. So what is the most a better solution to this? Let's say we have a list of classes, a list of interesting classes that we want to find in our stack trace. So we would have to create a list of class names. So here I'm converting my list of classes to a list of class names. Then I will have to create a, sorry, I have to make the image bigger here for me. Okay, now I have the list of class names. Then I will get the stack trace from the current thread, create a string. And from this string, I will get the class name from each stack trace element. Now I have a string of class names. Then I will filter for only the interesting class names. So the class names that are contained in my variable in my list of class names. Then I will find the first one, and then I will map to the instance of the class. As you can see, this is a lot of code. It's pretty unreadable. You can't see what's going on easily. It's error prone, so it's a lot of code, and you might make mistakes here. And also this had a bad performance because when you get the stack trace, you get an array of stack trace elements, and each object of this in this array, it has a lot of information, and this information is expensive to get. So doing this has a very bad performance. How does Java 9 solve this problem? Now we have a new class, stack walker, that you can get an instance, and you can tell what information you want to retain from the stack trace. So it's much more performant than the previous way. So here, for example, I need to find a class in the stack trace. So I will retain only the class reference in the stack trace, and I will walk through the stack trace. And when I walk through the stack trace, I will consume a string of stack frames. Then from this string, I will map each stack frame, getting the declaring class from this stacked frame, and filter by only the classes that are contained in my interesting classes list. And then I will find the first one. So it's much more easier to do, much more performant, and easy to read. So our code is much more have much more quality. Did everyone understood this? I'm not sure if I explained it well.
Can you hear me? So I'm not sure what is. I did not. I understand what the interesting classes are, but not what the retain class reference is.
Yeah, retain class reference is an option that you can pass to the get instance method, and based on this option, the object created, the stack walker instance, will know what to retain from the stack trace. Did you get it, y'all? Is that clear?
Yes, thank you.
Sydney is saying, I just never had need for that. Yeah. Probably for people that develop frameworks, this is more common. Java 9 has another feature, which is modules. When we develop APIs that are called by anyone, we don't know how the API will be called, and once we create them, we cannot change them anymore. We cannot remove methods. We cannot rename methods. So there's a book called 20 API Paradox that the author says that APIs are like stars, because once they are there, they will not disappear anymore, or they will be there for a very, very long time. So to keep evolving an API, we have to expose only what is API, and we have to encapsulate the implementation, so we can evolve the API with easy. Because if we expose the implementations, people will start to use these artifacts, and if we need to change these artifacts, we will be breaking code from the client. So this is not good. So how do we do that at Banrisul, in the company that I work? We use Osgi, which is a very powerful framework, but we have to use Osgi only to expose specific packages. So we are using a very powerful framework, but we use only one feature from this framework. So we are using like a bazooka to kill a fly, you know. And with Java modules, it allows us to specify what packages we want to expose. That is what we needed from Osgi. So we can expose only the packages that are API, and packages that are implementation we can hide from the client, so they can see or call them. So when creating a module, we can define its name. We can define the dependencies. That is a list of other modules that this module depends on. We can define the public packages. That is the core feature of modules. We can inform the service offered. We can provide service implementations that can be consumed by other modules. We can inform what are the service consumed by service consumer allows the current module to be a consumer of a service. I lost myself here. Allows the current module to be a consumer of a service. Oh yeah, it's the what service my module depends on. That's what this information says. And we can specify the reflection permissions that allows other classes to use a reflection to access the private members of a specific package. So about this feature, we could have an entire talk only about this feature, so I won't go deep in this one. But I left an article here, so you can check it if you want, which is a very good article if you want to go deeper into modules. I suggest you to read this one. Another feature that Java 10 has is type inference. For example, let's say if with Java 8 we are declaring a map, an executor service, and byte array output string. Do you agree that the type of the variable doesn't add much information here? It's a redundant information. So the type inference is that we can just put the keyword var in front of my variables, and the compiler infers the type of my variable. So we don't have to declare its type, and it's much more cleaner and easy to write. But this doesn't mean that Java is not type safe anymore. Once you assign a value to this variable will be a hash map forever. You can't assign a string, for example, in the next line. So it keeps the type safe. And I don't recommend you to use var everywhere, because it will be, your code will start to become messy. So I also left here an article from one of the authors of OpenJDK that this article has a lot of good practices using var. So I suggest you to read this one as well before starting to use the variable, to use the keyword var. Copying collections is another feature. Let's say if you want to copy a list, you would have to instantiate an array list, passing the original one. And then to make it unmodifiable, you would have to call a modifiable list to create a new object that is unmodifiable. The same for set and the same for map. And note that we are creating two objects to make this. We are creating an array list that is the modifiable one. And then we have to create another object that is the unmodifiable object. So we are creating two objects, and this is pretty verbose to do. With Java 10, we now have a new method, which is list copy of the original one, which is much more simple and cleaner than the previous one, and with the advantage of not having to create two objects. So it has more performance than the previous one. And we also have for the same method for set and for map. Collecting a modifiable list from a string is pretty similar. We would have to collect the items from our string, collecting them to a list, and then we would have to make it a modifiable in the same way that we did before. So here we are creating two objects as well. The same for set and the same for map, with the difference that for map we have to collect the key and the value. And now with Java 10, we just have a new method in collectors class, which is two unmodifiable lists. So we don't have to create another object to make our list unmodifiable. And we have for the other collections as well. Another feature is repeating strings. If anyone, if I'm going too fast, you can interrupt me and say that I'm going too fast, so feel free to do anytime. Repeating strings, so how we could repeat strings with Java 8? We would have to create a string builder and create a loop appending to this string builder the string that we want to repeat. For example, here I'm repeating the string s 4 times, and then return the value, the string from the string builder. Now with Java 11, we have a method for that. We just call repeat and inform how many times we want to repeat the string. So very straightforward and much more readable than this. Another feature now from Java 12 is indenting strings. Let's say we have a multi-line string. How we could indent this? We would have to split our string. So here I'm splitting the string by line breaks. So I'm creating a string of lines, and for each line, I'm indenting this string using the implementation that I showed in the previous slide. So for each line, I would have to indent the string, doing all this implementation here, and then I would have to collect all the lines together, joining all of them into one single string. With Java 11, we have a new method, lines, from the string class, which returns a string of lines. And so we can call this method, and then for each line in this string, we can call the repeat method to indent each line from the string. And then in the end, we would have to collect all the lines into a single string, joining them by break lines. With Java 12, we have a method for that. We just call indent and inform the indentation size. So as you can see, much more readable, and you can a lot of things could go wrong here in this very verbose code. So imagine how many bugs you are preventing not doing this and just calling a method that does the indentation for us. Another feature now from Java 14 is an enhanced switch. With Java 8, for example, if we want to do a switch to assign a value to a variable, we would have to do the old school switch. For example, let's say if we want to switch the day of week, in case of Monday, we would assign 42 to the variable value. In case of Tuesday, I would print today is your lucky day, and I would assign 100 to my variable. In case of Wednesday or Thursday or Friday, value is equal to 12. And in case of Saturday or Sunday, I would print, woohoo, it's weekend, and I would assign 50 to my variable. With Java 14, we have this new switch that I can assign to a value directly, and you can see that it has this arrow here. So in case of Monday, it's 42. It's like the switch is returning 42. In case of Tuesday, I'm printing today is your lucky day, and you can see this new word here that it's like a return from the switch. The variable value will have the content 100. In case of Wednesday or Thursday or Friday, it's 12. In case of Saturday or Sunday, I will print woohoo, it's weekend, and I will assign 50. Note that it's much cleaner, and I don't need the break keyword. I just return the value that I want to assign. And also, I don't need the default word here and what I would do with the default, because the new switch it knows that I'm using all the elements from my enum, so I don't need to use the default clause here. So pretty easier to do than in Java 8. Text blocks is something that I'm pretty sure that you already had to do. For example, creating a query, for example, or for me, it's pretty common that I have to create classes at runtime dynamically. So we have to write text blocks. And with Java 8, for example, if I had to create a query, I would have to create a string builder and append the break lines for each line that I want to break, and append the spaces for the indentation as well. So I would have to write a lot of code to create a test block, a string with multiple lines and with indentation. With Java 15, I just create a text block which is open, is delimited by 3 quotes, and I just write the string, and I can break the lines and do the indentation, and the variable, the string will keep all the break lines and all the indentation. So pretty much cleaner than this very verbose code from Java 8. Thiago is saying, thank from the presentation. About Java 14, I think there's a better way to identify null pointer. Do you know if Java pretends to be null safety or sound null safety? I'm not sure. I can't see any movement around this. Do you mean null safety like Kotlin? I did this presentation for another people, and they asked me the same thing. Yeah. I don't know, Thiago. I don't believe that we would have this in the short term. I don't see any movement around this, but I'm not sure. Yeah, Yao is saying that there is optional in Java 8 that makes it easier. I'm not a Kotlin developer. I don't know. I don't know much things about Kotlin. And for me, optional is great because I don't know nothing better than optional. Yeah, that's exactly what Thiago is saying, that it's not the same, but optional helps a lot. Yeah, probably Kotlin has a better way to deal with this null safety. Did I answer your question, Thiago? Sydney, you wrote, I despise text blocks. Despise, I don't know this word. Despise. Hate, okay. You hate text blocks from Java 15 or from the old ones? The new syntax? Yeah. You don't like the new syntax? Really? I like too much. Yeah, it sucks. I like the new syntax. Yeah, always asking that it comes from Python. Yeah, maybe. I don't know Python as well, but probably it was copied from Python or Kotlin. So moving on, with Java 16, converting a string to an unmodifiable list. As we did before in a previous slide, if we wanted to collect a string to a list, we would have to collect to list and then create an unmodifiable list. Now with Java 16, we have a new method in string class, which is toList. And then we don't need to use the collect method anymore. We just call toList, and we have an unmodifiable list without having to use collectors to list or collectors to unmodifiable list. So this is a very good feature, because I hate to use these collectors. And in other presentations, people told me the same, that they also hate. You probably also hate this as well. Java 16 has another great feature, that is records. You probably Thiago, that knows Kotlin, might know what I'm talking about. Let's say if I have a Pojo with three attributes, I would have to create a lot of code. Yeah, Yao is asking me to enlarge. Actually, I can't yell, but I will translate for you. As you can see, I have to create a lot of code that even fit in the slide. I had to let the font very small. So here I'm creating a person class that has three attributes. It has name, date of birth, and country. Pojo, yeah. Then I have my constructor to define all the attributes, and I have a getter for each one. Then I have the equals method. I have the hash code method, and I have the toString method. So I have to write all of this code here just to create a simple Pojo with three attributes. We have the project Lombok that allows us to annotate our class and our attributes. So we eliminate all this boilerplate here. We could just annotate our class with all args constructor, with toString, with equals and hash code, and project Lombok will create all these methods for my class. We can also annotate the attributes with getter annotation, and it will create the getter methods. Or at data, I don't know this annotation. I'm not really into project Lombok, because it's an external library. We would have to add an external library, and it manipulates the bytecode. So that's the price that we have to pay to have a very clean code. I prefer to write manually all the code. And Java 16, we can do this in just 2 lines, and it's pure Java. We create a record person that has 3 attributes: name, date of birth, and country, and that's it. We have a record with the attributes with equals, hash code, and toString in just 2 lines. Emran is saying case class from Scala. Yeah, maybe. I don't know Scala. Sydney saying, but records is not the same interface as a Pojo Java Bean. Yeah. With records, we don't have the getters, and the attributes are final. So it's not exactly the same. Yes, Sydney is saying that Pojo Java Beans has getters and setters. Record doesn't have getters and setters. You access the attributes directly because they are final, right? You can't, they can't change. So Thiago is saying there's a way to verify if the return of a class is a record. Return of the class is a record. Basically, I want to obligate every return method in an interface to use record to return immutable objects. I don't know, Thiago. I don't know if there's a way to verify if the return of the class is a record. But I'm not sure if I get it. Where would you like to verify? In the class that is returning, or in the class that is calling? Sydney is saying that you can use instance of. Yeah, maybe you can do a instance of record. Maybe, yeah, it might work. It might work. Probably it works. MRAM is saying in Scala we can add methods. I think record should allow adding. Yeah, actually you can add methods to record as well. You can override equals or override hash code or to string, or you can add your own method. It's much flexible. You can create a different constructor as well. Thiago is saying if there's a way to cause a compilation error if the person not use record. I'm not sure if I get what you're saying. Compilation error to force if an implementation, for example, is returning a record. I don't think it has a feature like that. I want something like generics, but with record. Maybe, I'm not sure, but maybe you can use generics and do something like that, for example. I'm typing up chat. Maybe you could do that, but I'm just wondering here. Maybe this might work. Okay, let's move on. You cannot extend record, yeah. So, Sydney, are you using? You are the one that are using Java 16. You seems to know a lot of this. It's like the bytecode of an enum. Yeah. Okay. So Sydney says he doesn't use record. Why not, Sydney? Do you have any problems with record? Many. Okay, we can discuss this after the presentation. Another feature is pattern matching for instance of. With Java 8, if we want to use an object that we tested, if this object is instance of string, for example, I would have to cast the object to string, so I would be able to call a method from string class, for example. With Java 16, now we can declare a variable in the instance of. So for example here, if my object is instance of string s, now we can access this new variable s, which already is a string. So we don't need to do the cast to be able to use the string. So much more straightforward to use, much easier to use. Sidney is saying that records conceptually sucks like enum. Yeah. Okay. It seems like its syntax sugar should create the same bytecode as the class. So going out to Java 17, we have sealed classes and interfaces. Probably this feature was getted from Kotlin as well. For example, nowadays with Java 16 and the previous ones, methods that receive interfaces or non-final class can receive any implementation. So we have to be aware of that and be prepared to receive any implementation in our methods. And besides that, these implementations have access to protected members of our superclass, for example. And we have to be careful to not expose internal stuff, implementation stuff, through these protected members. So we have to be very careful when exposing a method that receive a non-final class or an interface. And the Java 17 sealed classes solves exactly this problem, because with a sealed class or interface, I can define that this interface vehicle, for example, it permits only the class car and motorcycle to implement this interface. So if I try to create a class truck and implements vehicle, I will get a compiler error saying that truck is not allowed in the sealed hierarchy. So this is very good to restrict what we are receiving in a method, for example. So let's say if we want to create a class, a car class, which is a permitted one, when we try to create the car class and we say that implements vehicle, we also receive a compiler error saying that sealed, non-sealed, or final modifiers are expected. So we have to let it explicit what kind of class we are creating. So we can, for example, here I'm saying that my class car is final, and my motorcycle class is a non-sealed class. This is for not to make mistakes and create a non-sealed class without notice that this is a non-sealed class. So I have to let it explicit that the class motorcycle, for example, is a non-sealed class. A non-sealed class is a normal class that can be extended by any other class. A final class can be extended, and a sealed class, if I define a sealed class, I have to say what are the permitted classes that can implement my class or my interface. And that's it. I created a GitHub repository for you to start using these features today. All the examples that I used in this presentation, they are there. And there are other features that I didn't include in the presentation that you can find there as well. You can download the version 17. I will put the link here. You can download the early access build from Java 17. So you can start to test and experiment and maybe see what problems you will face when trying to migrate your project to Java 17. So if you want to do that, you can experiment with the early access build. The final version, the stable version, will be released in September. So I don't recommend you to use this in production because it's not stable yet. But you can start to experiment the new features with it. Any questions about that?
I can see some.
So Eyal, did you got excited to move from Java 8?
Well, it's definitely tempting.
Yeah.
But a lot of it has to do also with big corporations. It just things take longer. There are legal issues, I guess, that they have to look into, support issues, perhaps vulnerability. But vulnerability is also what will move things further eventually, because you want to, vulnerability-wise, there are more exploits on the older stuff over time. So I think 11 is a matter of time. 17 will probably take a lot longer. 11 is probably pretty close. Amazon, by the way, when we work on AWS, Amazon has their own JDK versions of 8 and 11, and it makes it easier to use their stuff. So I presume they will come up with the 17 once after 17 is out. And that also could make it easier for people who use, or companies who use AWS. Yeah, I use Lombok a lot, and it's something that once you use it, it's hard to go back. So I think having the records around is going to be a nice feature, and then you can do perhaps without Lombok or with less. And I like enums, so I'm not sure. Some people don't like enums. I do. Some of it is a matter of taste. It's a good thing that we can argue about what we like and what we don't like. But in any case, if anybody wants to comment or ask any more questions right now, you can put it on the chat. And otherwise, Helber and I, perhaps, if you still have time, Helber, to do that, we will go back to the table. That's okay with you?
That's okay.
We have time at least until 8, so we will go back to the table, and you are welcome to join us. If anybody wants to join us and continue the conversation or ask more questions, we will stay there. If nobody joins us after a while, we will close the meetup. and yeah, table number 1 again. And otherwise, this will also end our recording. We are recording it. It will go on YouTube in our channel in a few days, and people can come and watch it offline. So thank you for everybody who participated. Thank you, Helber. It was a great presentation. And see everybody next month on Jacksonville Java User Group. Goodbye for now.
Thank you, Eyal. Thank you, everyone. See you next time.